Yeah, smiling evening to all the CoderRange community. Today we are going to discuss something production scenarios of Kubernetes, and also we are going to discuss about this session is going to be for 1.5 hour time. In this community meetup of CoderRange, we are going to discuss the fundamentals of not going to be fundamentals of Kubernetes. It's going to be more deep dive. But someone who is beginner basic level, yeah, you have to excuse us because we're going to take up, if you are already having some basic level awareness, yeah, it's good. If not, we are going to deep dive into production level scenarios. So we are upfront telling you that to everyone, so that everyone, I do want to make your time more valuable today. Okay. So before we start off with the initial first 20 minutes, we are going to discuss about real production issues that we faced from my experience. So myself, Venkatesh, I'm a system architect, helped more than 110 companies so far, collaborated with 50 plus clients across India and international. Today, I'm going to share my expertise with Kubernetes, which I'm leveraging with various organizations. So I'm going to talk about the best learnings that I have got, I have able to resolve, or the conflicts are in terms of the deep learning that I have able to do it in Kubernetes. I'm going to share it with you guys. So let me talk about real production, right? So before I said already, this session for some of you who have joined, we are upfront telling this session is not going to be for beginner. This session is going to be more production scenario and in-depth concepts of Kubernetes with production scenarios. So kindly, we are trying to explain you this because if you are a beginner level, you will get some context of it. If you are someone at intermediate stage having awareness of Kubernetes, that will be great. So let me start off with this session. So before we start off with this session here, yeah. So for everyone, we are going to discuss about Kubernetes production. So everyone, you can be more focused because I'm going to give you great learning. That's sure. If you can focus, you will get a great understanding from production scenarios. I'm not going to talk about the basics, are not going to be about intermediate level. I'm going to talk about most advanced. So we'll be open for questions. But before that, let me start off with some real crazy understanding. So everybody knows what is Kubernetes. So Kubernetes basically is an orchestration which helps us to make our containerization scale horizontally or vertical. You can do that, right? So if anyone asks you a Kubernetes, in Kubernetes, we use a kubectl command, and we will try to use some commands to basically give that information of your YAML file, whichever you type it, right? Any Kubernetes information that you are giving generally, right? So whatever Kubernetes API which you are talking about, right? This Kubernetes API is basically where we interact on kubectl or kubectl get pods, right? This information, whatever you are giving using command prompt, will be shared to etc. Okay, etc is basically your cluster which will store your actual configuration of your YAML file. Okay, but this etc cluster will actually have a key value store pair which will actually have nodes. Actually, etc will be managing nodes, node 1, node 2, node 3, and each node can be a leader and followers. Okay, now I will talk about this only real time. So let me explain you an example. Suppose in a real production, let's say you are writing one command, kubectl create deployment, like this. You are writing one command. The moment you write this command, what happens? Okay, let me discuss that. The moment in kubectl create, if you write this command, that command is going to interact with Kubernetes API server. This Kubernetes API server will write the information which you wrote in YAML file into etcd. So etcd is storing the data that is related to your deployment. Okay, it's replicating across nodes or whatever it is. Generally, etcd will be storing this information with one node, one is leader, the other nodes are followers. If the leader fails, then etc will select a new leader automatically. This is how a basic real production happening. The Kubernetes scheduler will control that, and kubelet read from the etc, and whatever you want to do that, do that. Now, this diagram and this explanation should be matched for you guys, because whenever you write any command, kubectl apply some YAML file information, This is going to be basically storing this information in your etcd. Etcd is the one which stores. For example, for instance, I'll tell you. For example, if I have written this YAML file, for instance, if I write this YAML file, okay, this is my YAML file. This YAML file has a kind deployment. Okay, this YAML file, if I write a command kubectl, you can see here, if I write kubectl some deployment, if I do this, the information in this, the data which is there in this YAML file is basically stored by your etcd. Okay, etcd will store that information, what you have written in the YAML file. And this etcd internally manages with help of multiple nodes. Okay, and why these nodes are necessary, I'll talk about this. I'll talk about a real production scenario which I got. I'll explain about this. Let me give you an explanation. In a real production scenario, which I'm going to talk about here, all the real production scenarios I'm talking about, etcd is nothing but which stores the key value pair, that stores your cluster state. Means etcd is the one which stores your information like number of replica, what is the current state of your cluster, what is the desired state, current state. It will manage that information, right? Now, if you go and see this detail, very detailed, if you want to see this, let me give you a real-time production scenario. Okay, basically in the production, if the etc is a key value thing which stores cluster state only, but there is an API server which talks to etc. Okay, generally the API server is the one which is talking to your etc. And then below this, what happens? There's a scheduler decides which node to be created, and the controller will check, ensures that if your desired state, it will check whether it is desired state is 1, then it will ensure that the desired state is current state with this desired state. And there is a kubelet which will, if you are using any command to talk to API server to get the pod, kubelet will do that. And this is all happens in the data plane. The data plane is actually the pod and container, which is pods run trained by this thing. Okay. Now, I'm not going to talk about any design or aspects now. For all the beginners, I'm going to talk about a production scenario. You can take this production scenario, which we have really resolved it for one of our client. So let me tell the core design principles. So most of you would have worked with Kubernetes. You can use a comment also in a comment box. Some of you are already having Kubernetes experience here. I know that. In your real production, right? We all work with two planes, control plane and data plane. Okay. So control plane is the one which we scale etc horizontally with shards. And we use API server behind load balancer also in control plane. Data plane is actually where your pods actually run in the real production. That nodes are optimized with kubelet and containerization, and high pod density will happen. Around 300 to 500 pods per node will be there. And there will be observability layer also. There is a log metrics which they'll collect. Okay. And there is a networking that will happen generally. Now, for an instance, I'll give an example. In a real production, this is how it happens. There's a control plane. The control plane in Kubernetes contain API server, control manager, and scheduler. And as I told you, the etcd will have 3 to 5 clusters. Then it was again having a data plane. In the data plane, let's say I can have 2 nodes. Each node will have been configured that we can have some pods running around 500 pods, 1000 pods, 2000 pods running in the production level. Let's say your data plane has 10,000 nodes, which we have to have created. And then this all are managed. The control plane and data plane is connected to your observability. Observability is your networking layer. That is, it will have the information on logs, metrics, and pipeline, and it will contain the service mesh and all this information. Okay, this is a general strategy here. Now I will show you a real production. Can everyone see here with smile, all of you? Do you see a production scenario we have faced? Before production failure, there was 1 million pods and 10K nodes. Okay. And the logs and metrics, when we are, you can see it was this way. It is this way. After stabilizing at scale, okay, which we are able to do with managing multiple etcds with, and then service mesh, you can see there's a stable kind of graph, right? this production issue which I'm talking about now, this is a production issue. What happened before and after? I'm going to talk about it. So before, what happened is in our production. So yeah, before in the production, what happened is the ETC became a bottleneck, and you can comment. Some of you here who have worked in production, tell me if you have faced any issue with ETCD. Okay, ETC became a bottleneck. Why? Because the logs and metrics pipeline chokes and nodes get overloaded. Nodes overloaded means what? The pods will fail. Okay. Then what we did is we make sure ETC is shared across multiple clusters, and the pods are balanced, okay, with tuned and kubelet. Okay. And observability is also make sure we are doing that observability and handling all the failures. Okay. This is one of the things we did it. How we did this? Let me tell you. So your control plane is there, right? Your control plane before failure, it was single etcd cluster. There was a bottleneck because the API server is overloaded with 1,000 requests. Then how do you handle it? Then what we did is we improved the infrastructure. We make sure that etc is shared across multiple clusters, and then we had API servers running in behind that load balancer, and then we did a compact fine tuning with this, so that the control panel was able to handle millions of state changes. And we also had one more issue with your nodes. So before that, what happened? Your default kubelet configuration, frequent GC, means garbage collector process was happening. Then even Docker runtime overhead was there, because Docker image size was larger and application was that issue also we faced it. And then slow pod startup also we faced, and pods per node were limited. There also that was issue. So we resolved this issue by switching from Docker to containerization for lightweight runtime. And we made that node fine-tuned with some aspects of configuration, like how many pods we want to have, disable unused admission plugins, and we make sure 40 to 50% pod scheduling faster, right? Now you might get this all we did as a practical real-time scenario, like networking, observability, custom CRD scheduling. We had every aspect of implementation. Prior to that, we were implementing a raw cluster. Now we implemented multi-cluster. And then observability also, we had a Fluent D sidecars, heavy resource usages. Then we switched to Fluent Bit actually, which is lightweight and tired storage. So lot of improvement as an overall system we have done. By doing that overall system, actually what we did is failure state was there, single etcd was there, API was getting overloaded. Then we made a sharded etcd, and then we improved the infra and system design. Both we did. Nodes also, Docker runtime 100 nodes per node was there. We fine-tuned it to 500 pods to nodes. Networking, observability, every aspect of it we try to improve it here. So let me give you a real production, so you can take it more in the real time. Generally in a real production, what happens? If a user is there or any client is there, it can be mobile app or web app. If they are talking to ingress layer is ingress controller is there, which is basically they talk to that will again talk to API gateway. Then from API gateway, you go to service mesh. Then service mesh will take it to, that is a traffic layer in real production. And then it will have service to service encryption will be there. There will be global routing will be there. A lot of real-time aspects will be there in the service mesh. Then they will interact with your Kubernetes core. That is your API server, scheduler, control manager, etc. Then what happens? This Kubernetes core will talk to worker node. The worker node actually has the parts, applications, and your daemon sets, agents, logging, monitoring, and up to there will be some 500 parts, best practices that you can implement. Then real production, we majoritarily implement observability and pipelines, because we will use the Fluent Bit to make sure the logs, metrics, traces are done. And we ensured in real production through aspects. Maybe some of you might be aware. We use something called zero trust layer. That is zero trust layer we implemented, and RBAC with security and pod identity with secrets management with walls and all, we manage it. So this is a real production implementations which we have discussed. And if you ask me here, we had an issue with what? You might get a question. Venkatesh, what you really had an issue? Means in a real production, if you take an example, which I'm already demonstrating, in your real production, if you are not managing your control plane properly, your data plane, if your control plane is not managed properly, irrespective of that, this control plane, if you manage with only one or two etc shards, you will be having a big overhead in the production to scale it also. So what we did, we entirely managed the production scenario like this. How? We make sure etcd stores the cluster state. Okay, that we will set up generally for high setup. We 3 to 5 nodes we use it, and we use a pod spread. The scheduler will spread across workload, and we implemented log metrics and pipelines. That is your Grafana to visualize it, and Fluent bit is to collect the logs actually. Then we handle the secure service to service communication, retry or failures. And we used all the zero trust security to make sure every pod is authenticated and encrypted. This is what we did in the production. So you might get a question, Venkatesh, in the real production, we haven't got any issue related to this. If you say, you can comment in the chat box, or if you have come across something issue like this, you can